Oh, hi everyone. Welcome to this session. I'm very excited to be here. This is Fahrenheit. I'm a data scientist here at IBM, and I'm very excited to be part of this. We are going to have a hands on workshop on building an shopping assistant that's powered by LLMs. And I'm very excited to um, introduce you to some of the core concepts. I'm sure that there is a lot of great information out there so far on different sessions. So I'm not going to go into too much depth, but feel free to ask questions whenever you face any concerns or issues, and let's get to it. So we will go a little bit about what's generative AI and the overview of the app, the overall architecture of the app, and the API that we're going to use and the technologies that we need to build this app. Um, so what is generative AI? By now, I'm sure that you have a good understanding of what generative AI is. Basically, it generally refers to AI models that are capable of creating new data like text, images, music, based on some training data that they had. The some of the examples are like ChatGPT for text, or like Dolly, Granite Code. That's an IBM model for generating great code, and I can automate, like generative AI models. They can automate and create complex and solve complex tasks. It can create a bridge between what user intends to do and what needs to be done. And we will learn in this session how to effectively design prompts and get a structured output and use APIs in real time and create a functional web application with Flask. This is an overview of the app. We are going to mainly use Flask and an API called SerpAPI that connects to Google search engine, and LLAMA model 3.1, the 70B model that's hosted on watsonx AI, and some HTML and CSS for formatting our website. Um, so what is an API? Uh, APIs are application programming interfaces that allows software and applications to communicate with each other, basically. Some examples are a Google Maps API, or Google Search Engine APIs, or weather APIs, or like financial data, like a stock market APIs, all those. And they can be very handy when we're creating an application. So for this particular workshop, we are going to use SerpAPI. That's the Google Search API. And it lets you connect to the database of all the products that are available online in the market. And you can prompt it a little bit with like what products that you're looking for, or what location are you looking from, and get a list of products. So I would like to invite everyone to go and sign up for this SERP API key. You will need it for this workshop, and you will be using it. So you can create an account with your Google or Gmail accounts, and the API key is completely free. It gives you 100 searchers a month, and it is more than enough for the purpose of this workshop. So while we're going over this, I'll give you some time and in the end to go and register for your API keys, but I suggest that you start the process now. In working with LLMs, We are going to use a model. We are going to use Meta's model to generate some text, but not just like a general prompting. We are going to actually do some prompt templates. We're going to create some prompt templates that will help the LLM to generate more precise answers. And it is very important to leverage using prompt templates when you're building an application, because you want the outputs to be reliable, right? So um, in this particular project, we're going to use the Meta LLM to transform inputs from users into precise search terms, to summarize the products that we are getting from that external Google API. And we are going to use the LLM to structure the output in an HTML format so that we can show them on our front page. And some of the key concepts that we're going to use is the use of prompt templates and output parsers, and we are going to use LangChain for that. For this particular project, we are going to use a greedy decoding method. If you're not familiar with it, it's totally fine. It's basically determines how the AI will choose the words when generating text. And we have two options. One is the greedy decoding and one is sample decoding. Usually, the default mode is set on sample decoding, and it gives the LLM to create more creative and versatile responses. But for creating an application and making sure that you can rely on the generated outputs, we prefer to go with greedy decoding here. You probably heard about like some parameters like temperature, top P, top K when working with LLMs when inferencing. But when you use greedy decoding, it basically outputs the most deterministic response from the LLM. So there you don't need to um, be concerned about all the other parameters like temperature, top P, and top K. As I mentioned before, we are going to use Flask. That's based on Python. It gives a great flexibility to create the front end. And it's very easy to get your hands on, because there are some very simple Python functions that you can use in your programs to create a front end and a simple web application, basically. It's very lightweight, it's very flexible, and you can use it with different HTML templates and handle requests from APIs with Flask. So it gives you a great flexibility. So this is the overall architecture of what's going to happen, but I'm going to come back to this slide after we get our hands on the application itself. No more talking, and let's get into the actual workshop. Let's build the app together. So now I want you to follow this link. I believe it's already put in the chat for you. So just please follow the link, create an account on cognitiveclass.ai. It's completely free. And I'll give you like 5 minutes to go over this process, and then we can start building the application together. Thank you. Okay, great. I can quickly show you what's the website look like and what we're going to work with. So if when you go to cognitiveclass.ai website, there is this button for registration, and after you register with your email and your ID, then you can sign in into the platform. You can also access um, the project that we're going to work on using the search function, and you can enroll by clicking on this button. Okay, great. By now, you must be in this screen, and let's start building. So this is the way that the application will look like, and we'll get there in a few minutes. So just to give you a brief introduction of what the platform looks like and how we can navigate around, the guidelines and instructions are on the left. You can see here. You can scroll, read through the instructions, and you can go to different pages and follow the instructions as we designed it. You can also go through different tabs at any time that you feel lost. Don't worry, you can go to this table of contents and find where you left off. There are some tips for the best experience with the platform that I'll let you go through it after we're done with this workshop. There are some general tips about how to navigate through this platform. Um, okay, then let's get to it. First, we are going to clone the repository that um, we that we have all of our codes on it, and then we go through different parts. So you can just click on this little arrow here, and it will execute this code in your terminal. If we go through the directory, you can see that now everything is all the files are here. Then we can we'll create a virtual environment, and we install all the dependencies that we need and all the libraries through clicking on this button here. Basically, what we're doing here is installing all these libraries like Flask, SerpAPI, the IBM's watsonx to that the LLM is hosted on, and LangChain, and some other libraries like Google Search and Pandas. And here, we wait a little until we have everything. And we open our SerpAPI Python file. Here is where you need to put your SerpAPI key, the one that we generated earlier. I will give you 2 more minutes to go and create your API key. After you create your account on SerpAPI and get your API key from your dashboard, you can copy it and paste it here. I give everyone some minutes to make sure everybody has their API keys. Okay, very well. Here we have everything that we need to go through our app. Now we need to run our main application app, the app.py. So when you run it, if everything is working correctly, you'll see some lines like this. It's showing that the Py file is working correctly. And now is the time to launch the application. So by clicking on this button, you can launch the application. You can see here that now we have everything ready for application, and let's give it a test. So let's say we are looking for a gaming laptop in the best city of the world, Toronto. Just kidding. Let's give it some time for it to process. I'll let you go through the instructions and get to this step, and I will refresh the page because sometimes this happens. Just one moment. This is one of the fun moments of working with LLMs. Just give me one moment, please. In the meantime, just feel free to ask any questions that you have. Okay, let me share my screen again. Sorry for the inconvenience. We are going to put our API key again, and let's run the app again. And let's give it another try. So let's say we're looking for a gaming laptop in Berlin. Okay, it's taking some time. It means that the app is working actually. Sometimes it takes a little bit of time for the LLMs to inference and get the results. Okay, so we can see that the our app generated some outputs. You see that here we have this refined query that was generated by the LLM and a table that has the links of all the products, the prices, if there is any promotions going on, and what the store that the products are presented in. We also have an interesting part created by the LLM, that's a summary. So we can see that it's offered some of the best value products, what's highest rated amongst all of them, what are some of the unique features, trade-offs and comparisons, and in the end, a conclusion that which product the LLM thinks is best based on all the information that it got from the SerpAPI. So we are going to go a little bit more into details of like what different functions are doing and how they can be integrated into this final application. We can give it some more testing and for you to see what's going to like what's going to happen if we look for something else, like for example Valentine's gifts for my mom in let's say in Dubai. The location part is important because it gives the SerpAPI a clue of what market to look at, basically. If you look at here, you can see there is a generated country code. We're going to talk about it later, that what it means. And it is an interesting feature of the LLM here. So here you can see it's refine the query, and there is this table of like different gift ideas for a mom on a Valentine's Day, and all the conclusions and trade-offs and other summaries. So let's dive deeper into what's actually included in this project. So we have different directories. That's the overall architecture of our app. And if you follow the instructions on your own time, you can test how you can create a very simple Hello Flask application and how you can run it on this platform. But we are going to talk more about what's the LLM part in the application. So let's get to the LLM part and the breakdown of how we implemented LLM here. First of all, we need to initialize the model that we're going to inference and we're going to access. For that, we are using this watsonx LLM wrapper that gives you access to different models, the llama model included. And these are some of the authentication parameters that you need to put in um, so that you can access the models. Actually, this is one of the strengths of this platform. You don't need to pay for any of these. All of these are included for you to test and educate yourself. We earlier talked about the decoding method as one of the model parameters for our LLM, being the greedy because we wanted to generate deterministic responses. And one other key concepts when working with the LLMs is the output parsers. So we want the output of the LLMs to be reliable and readable. Here we are using a JSON parser, and we mostly use it for refining the query. So we don't know what the user is going to input inside this search box. With this part, we are going to identify what's the properties of the query that you're looking for, basically. And we, as I mentioned before, we're using a prompt template, and we are using a system prompt, format prompt, and human prompt for our model. This generally helps the model generate more precise outputs. So instead of just prompting and saying, create me a list of all the products um, that's on market for a gaming laptop, for example, you can structure your prompt and and have more control of what the LLM is going to generate, basically. So you saw on the app that there is a field for entering the location. The reason for that is the way that SerpAPI works is through having a parameter, a location parameter that's a two character geographical location code that lets the SERP API to connect to the database of that a specific region or market. For example, if you're looking for something in Toronto, it needs to connect to Canada's market. If you're looking for something in New York or Berlin, it's different how you call the API. It was one of the challenges of this project, and the way that we solved it was by using an LLM to actually generate a two character country code or GL code for the SERP API. You can see here that we are prompting the model to give us this two character string. So we define this function with a system prompt, a format prompt, and a user prompt. You can see here that the system prompt is you're an expert at identifying the alpha 2 country codes from locations and output only two-letter country codes. Although we have this here in the system prompt, sometimes the LLMs still can generate more information, not only the two character code. So adding a format prompt will help. Again, we are emphasizing that we want the format of the output to be alpha 2 country code only. And then the user inputs the location. And this location is coming from that search box on our application. We chain everything together using this concept in LangChain that basically we are feeding in this template that we created earlier using our system prompt, format prompt, and user prompt. And we are feeding it into our LLAMA 3 model. And the output would be the GL code. And this is what you can see here when you run the application. You can add some debugging controls like printing it in the output of the terminal to make sure that it's working correctly. Another aspect that LLM is helping us in this application is in refining the query. So the user might input something like, I want to play video games on a high-speed computer. The LLM will read that um, prompt or that query and refine it into something that's more optimized and more suitable for searching through a search engine, and this in this case through SerpAPI. So again, here we are using an LLM to refine the query. We are asking it to refine the user queries into some specific product searches. And again, we are using that template concept and that prompt template concept to train our LLM and get a response. Here you can see that we are asking, we are training the JSON parser because we want the output to be in a JSON format. And later now we get to actually creating or generating the comparison table, the one that you're seeing here. So what it inputs is the products coming from the SerpAPI that was requested through our Python application to the SerpAPI. So we get the list of all the products and we select the first 5 of them to show on this table. This is completely arbitrary. You can go up to more to see a list of more products like 10 or 20, but be aware that this is the table that you are feeding into the LLM to generate summaries, so you have to be cautious about the context length. You cannot give it like 100 different rows. It will cause the LLM to create some incomplete responses because the context length is already um, fed. So when it gets the products, it generates this different product summaries from the JSON, the products JSON file. That's the output of the SerpAPI. So you can get the name, the store rating, reviews, everything clean and neat like this from your JSON output, and create a summary. You can see here that there are 2 different dictionaries here. One is the overall product summary, and one is for the LLM. The reason for that is we don't need to give the image or the links of the products to the LLM to generate summaries, because again, we don't want to overwhelm the context window of our LLM. Now that we have these data frames of different products, now it's the time that the LLM enters to generate summaries of these products. So finally, and last but not least, we get to the LLM generate summary function. Again, we are using system prompt, format prompt, and user prompts for this purpose. And you need a little bit of trial and error to get to an optimized prompt to get you where you need. For generating this, because it's a dynamic table, and it's some dynamic data that's coming in, and you want to output it. So one of our colleagues came with this idea of actually asking the LLM to output the results in an HTML format, and then directly feeding it into our front end and showing it. It was very genius, actually. So, main takeaway of this part for you can be to think about, you can be creative in how you ask the LLM to generate the responses for you. So, it can be something other than just a simple text generation. You can ask it to generate in a format that you want, and one of the formats can be HTML format, for example. So how we are doing it here is that we are telling it both in the system prompt and in the format prompt that we want everything in a valid HTML format. And then we can add some fallbacks and safeguards regarding to when it doesn't generate any HTML. And we can just add a line, something like the summary is unavailable, so that we can later come back and debug our application. But with this main function, now having the product summary table, we can we can prompt the LLM to create all these different sections of what's the best value product, what's the highest rated option, or for example, unique features, whatever that you need. So basically here you can customize your app, and you can trial and error and see what exciting things you can come up with this application. And if you follow the instructions, you can see that there are different instructions for this different parts, different sections of your this application that you're going to build. And one cool feature of this platform is that you can copy everything. You can open them on the left hand side. You can open the files on the left hand side and paste everything. And then you can also customize the app. Let's go through it and let's give it a try. So imagine that here we want to customize the app and ask the LLM to generate its responses based on not 5, but for example 10 different products. So let's find where we are giving it the list of the products. Here, for example, let's change it to 10. And let's run the application again. You see here that it detected that the file changed, and again it rendered the application. So you can just refresh it and search for something like a mountain bike in New York. I don't know why somebody would need a mountain bike in New York, but let's just assume. So you see here that this generated country code that's powered by LLM here is identified as US. We have this refined query, and you see that there is only one product here. It's probably because they couldn't find any more options. And you can see that cleverly is saying that there's only one product, so I cannot like provide any comparisons or anything like that. So let's try something else. Let's try our gaming laptop. Let me just make sure. Yeah. Delhi. Okay, I think the problem here is that when we change it to 10, it didn't actually refresh the application with this new number. Let's give it another try. Again, it's fun of having live workshops. Let's see. Yeah, here I think the problem then was that it only detected one, not the 1 0 in the code. Anyways, you can see here that now we have 10 different options, and the comparison, the summary is based on those 10. So I invite you to go through the codes and just familiarize yourself with the overall structure of the application and play around with it, especially the prompting part. You can see how even minor changes in the prompting can lead to different outputs in your application. You can also customize these different boxes, and you can add more to it. I also invite you to look at the SerpAPI documentation for more options on how to get like different products information. For example, deals or reviews. One next step from here could be going actually through the text of the reviews and not only the ratings, and come up with a comprehensive list of what's the best value product, or what are some of the um, trade-offs for each of the products. Now I want to go back to the our presentation. Let me switch back. Uh, So this is an overview of what we achieved here. We started by getting the user inputs and the location on the homepage, and I can share this slide deck with you later. I'm sure it's gonna be in the recording as well, and you can come and review this and see where in our application all of this is happening. But to just quickly review of what we did, the user inputs the query, the LLM refines the query and adds some context to it. Then the LLM generates the country location code, the two-character code, to correctly connect the SERP API to the correct database. SERP API fetches products, and it uses that refined query and location. Then we use pandas library to generate a comparison table based on the products and feed that table into the LLM again. The LLM then generates an HTML formatted summary of the products and display the refined query, the comparison table, and summary in the front end. You can check more exciting projects on cognitiveclass.ai, like how we did and what we did here. You can follow the instructions and deploy apps or learn about concepts in Jupyter Notebooks. We have a very broad list of projects there, and I'll be happy to connect with you on LinkedIn, and you can check other my other projects on Cognitive Class using this QR codes. I think we have a few minutes if anybody have any questions. Yeah, so we have a question saying, how do LLMs understand multimodal inputs, and does prompt engineering work well for multimodal output generation? Actually, that's a great question. We have some projects, and we have many exciting projects on multimodal LLMs. So basically, you need first, for your LLM to understand the multimodal input, the LLM has to be trained on multimodal data, and it has to be specifically targeted for a multimodal input. I know that, for example, LLAMA has a multimodal model, and OpenAI has a multimodal model. And then there is some different structure for prompting and some similar but different libraries that you can use to input the images or images and text or voices. And another key concept about that is that you need to encode the images and other file formats before you are inferencing the model there. There are again some libraries and there are some tools for doing that. And I invite you to check for it on Cognitive Class. I know there was another session done by Haley on a nutritional coach app that actually takes in an image and gives you all the, for example, calorie information of the foods that are in the image. So you can find the link somewhere around here on this Be My app and follow the instructions there. Okay, if that's all, thank you so much for tuning in. Looking forward to more sessions in the future. And yeah, let's connect. Thank you.